Welcome back. In this unit, we cover joins and strings. We'll have two videos. The first is slide heavy, I'll admit, but I think that joins are a very visual topic, so we'll go through the different examples. Our second video will cover strings and an example that pulls together previous material as well as this unit's material. So let's talk about joins. Why do we bother with joining our data? What does it mean? Most datasets aren't going to have absolutely everything that you need, and sometimes it just makes sense to pull in variables from other datasets. A primary example of this would be turning abbreviations into full names. So for example, you might have country codes that you want to turn into full names for your visualizations or for your analysis. Information essentially is going to be scattered across different datasets. In the airlines, flights, airports, and so on, data from our textbook is a good example of this. But just because you want to join data doesn't necessarily mean that you should. There has to be an identifier or the key in common for you to merge. So it has to be intentional. There has to be a reason. Why exactly can I merge these different data sets? So to determine if a join makes sense, what you want to do is ask yourself, one, what columns or individual column uniquely identifies each observation in your data set? So what is its key? The next you want to decide is what are the common columns across different data sets. So for example, here in flights, we have things like year, month, and so on, and in weather, we have the same columns in common. And sometimes our columns might have the same names, but they might mean different things. So for example, two of these data sets have name columns, but they refer to the airline versus the airport, respectively. So these are the things that you need to explore. What are the keys? What are the things in common? And what are things that look like they're in common, but actually aren't? Keys. Keys are a variable or a set of variables, so you can have more than one, that uniquely identify an observation. And you've been working on determining these through your previous challenges. These allow us to identify a unique case or observation in our data. So for example, a single key could be a tail number on a plane, like the airport's data, or it could be something like a respondent's unique ID. Or it could be multiple columns, so date and origin for weather and flights, and then country and year in our polity data. For example, baby names is actually the name, the year, and the sex in order to determine a unique case. The primary key is the variable that uniquely identifies an observation in the primary data. And by primary data, we mean what is the main data set that you're working with? What is your first data set is what I like to think of. The foreign key is the variable that uniquely identifies an observation in your foreign data. And this is the data that you're pulling in. This is your secondary data, which you're adding on. And then if your data doesn't have a key, that's okay. You can create one, and that would be called a surrogate key. When you determine a key, there's a few steps that you need to take. The first, you need to check if this column uniquely identifies each observation. You can do that using count. Essentially, you don't want keys where n is greater than 1. Each row needs to have a unique identifier, so you don't want to have the same value twice in the data. And then you also want to check if there's missing values, which you can do using is.na. And this, again, you just don't want any NA values, or else your two data sets won't join properly. So I'll show you how to check that in our script. There's two main types of joins that we'll cover. Now there are others, but you're not really going to encounter them in this class, so read it in the textbook if you want to learn more. The first is a mutating join. This adds new variables from one data frame from matching observations in the other. There's a few different examples. For mutating, just remember you are adding to your original data frame. Filtering joins filter observations from one data frame based on whether or not they match an observation in the other. For here, you are reducing the original data frame. So mutating is when you want to add new variables. Filtering is when you want to reduce rows in your original data. And we'll go through mutating joins first. Inner join. This is the first type. In an inner join, only observations, so your rows, that are in both the primary and the foreign data sets are returned. So here, this is our primary. X is always going to be our primary. Y is always going to be our foreign data. We have keys of 1, 2, and 3 in here, and then 1, 2, and 4 in our foreign. And in an inner join, it's only going to return those keys that appear in both, so just 1 and 2. And it's going to return all of the variables in both of the data sets. So here we have this X value and this Y value, and you see that both of these columns are returned. A left join is similar, but all observations that appear in the primary data are returned, regardless of whether there's a match in the foreign data. So if it's in the primary, it's being returned. And similarly, all of those variables are going to be returned from both. So here in our primary data, we have 1, 2, and 3 as our keys. In our foreign data, we have 1, 2, 4, and then we have this NA value. In our final joined data set, we're going to just have 1, 2, and 3, all of the observations that occur in the primary data, and then we have columns from both. So here, there is no 3 row in this foreign data, so we're going to have an NA value in that column. The right join is essentially the same thing. The only difference is that it returns the rows that appear in the foreign data. I almost never use a right join. I exclusively use a left join. And the only difference is what data sets we feed first. So R is always going to register whatever data set you use in the join function first as the primary data. It's always going to register the second one as the foreign data. So here, our foreign data is what's returned. So we have 1, 2, and 4. And then we don't return the different value from the primary data. Same thing. Finally, we have a full join. This is usually not appropriate because it returns all of the observations in both primary and foreign data, as well as all the variables. The reason why I typically don't suggest is because you're going to get a lot of NA values. So here we have this 1, 2, 3 column, we have this 1, 2, 4 column, and now we have NA in value Y for the row 3, which was originally just in our primary data, and we have NA in value 4, which was originally just in our foreign data. It doesn't seem so significant when we only have this small number of cells, but in a giant data set, those NA values are going to become really, really frustrating to deal with. And so here's another visual of how you can think about this. For an inner join, you're going to keep only the observations that occur across both data sets. Left and right, you're going to keep all of the observations in the primary, or you're going to keep all of the observations in the foreign. And then here in the full join, you're going to keep all of the rows. So full joins are pretty messy. I don't recommend them. Left join and inner join are going to be your most commonly used mutating joins. There's a few arguments that you should be aware of. The first is by equals. You always want to specify this argument. So what this does is it tells R what columns to join by. What are the keys? You can join on more than one column. So if a combination of columns uniquely identifies those observations, so maybe it's year and country, for example, you're going to say merge by equals C, column 1 and column 2. If it's just a single column, it's just going to be by equals column. Now let's say those columns are named differently across your data. Here you're going to specify that column 1 in your primary is equivalent to column 2 in your foreign, and so on. But you just want to make sure that you're always telling R what columns to join by. Now let's say you have two data sets and both of their keys are just named ID. Sure, R is going to know that it wants you to join by that, but it creates a lot fewer headaches if you specify using the by equals argument. Now this argument isn't nearly as important. The relationship equals argument is not one that we're going to typically use in this class. I just want you to know that it exists. So it automatically defaults to null. And essentially, when you don't specify this, R doesn't expect there to be any relationship between your data. So it checks for a many-to-many relationship, and it's going to warn if one occurs, but typically it's just going to read in fine. I show you this in case you do have errors or if you want to specify any of these relationships. So 1-to-1 means that each row in your primary data matches at most one row in your foreign data, and vice versa. There's only one in each that can correspond to each other. 1-to-many and many-to-one, the inverse of each other. Essentially, a row for 1-to-many, a row from your primary data can match any number of rows in your foreign data, but a row from your foreign data can match at most one. So these, again, aren't super common. If you do have this and you want to make sure that R reads it that way, you can specify this. And then finally, there's many-to-many. Many-to-many is when a row from your primary data can match any number of rows in your foreign data and vice versa. And typically, that's going to mean that there's something wrong with your join or that there's maybe not a good compatibility between your data sets if you want to do this. Again, you typically don't have to specify this relationship equals argument, but in case you get the warning that there's a many-to-many relationship in your data, I want you to know what that means. And I am going to quiz you on it right here. So I want you to run this code in your own console, read in the data, so you have an X and a Y tibble, and then I want you to figure out what is the correct relationship in joining X and Y. So look at X, X2, X3, X4, and then Y1, Y2. Those are our values, but our keys are 1, 2, 2, and 1, 1 and 2. What is the relationship between the keys here? And I'll give you a second, pause, read in the data, and then this is what your quiz question will be. All right, moving on to filtering joins. Again, these are far less common, but I want you to know how to use them. A semi-join is when you keep all observations in your primary data that have a match in your foreign data. And unlike mutating joins where you add variables from both data frames, here only the variables in your primary data are retained. So here we have a match in 1 and 2 in this data set. 3 and 4 don't match across the two different data sets. So we're only going to keep 1 and 2, and again, only the variables from that primary data. And then our anti-join is going to drop all observations in your primary data that have a match in your foreign data. And again, only variables in the primary data are retained. So here, 1 and 2 match, we're going to drop them, and we're going to keep everything that is not matched in the foreign data. Not used super commonly, but they can be helpful in the face of or as an alternative to filtering. So practical use overall. When you're thinking about a join and you want to know what type of join you should do, your questions should be the following. What information does each data frame contain? What is it that I want to pull in from this data or exclude from this data? And then the next is, so do I need to match, like for example, let's say I want to pull in weather into flights. Do I need to match weather information to every single flight, or do I just want a subset of them? That's when your filtering join might make sense. And then another question is, do I need to keep all of the columns, or am I really just looking for one column of data? So for example, let's say I want to pull in planes, tail number, and let's say it has the full plane name. I don't actually remember what is in this data set. If I only want that column and I don't care about the rest, then I can just keep that one column through selecting. But this way, when you merge your two data sets, they don't become just overwhelmingly large. So think about keys, think about what information you need, and think about if you need the information for all rows or if you're really looking for just a subset of your rows. Let's go to our script for some examples. So here, as always, we're going to start with tidyverse and NYC flights, which largely is going to follow the textbook examples. We have a lot of data that we can pull in. So we have airlines, which records carrier code and the full name of each airline. And I list out the primary keys for each of these. So carrier is the primary key for airlines, and FAA is the primary key for airports, and so on. Let's double check if these keys are good. So first, we're going to use count. And count just helps you count the unique values within a variable, very similar to ndistinct. And we're going to say airlines, count on that carrier column, and I want to filter for anything that is above 1. And what we do is we produce a data frame with no observations, which is good. That means that each value in this carrier is unique, which is exactly what we want. We can do the same thing for is NA. So is, it returns if the value is NA or not. And we want to filter to see if anything is an A. And again, great, there's no NA values, so we know that this is a good key. On your own, if you want to practice, go ahead and practice checking the keys in the planes or the weather data. And weather especially, both of these, weather and flights have those compound primary keys. So let's practice joins. And actually, this should be mutating joins. Let's practice mutating joins. So let's say, for example, we want to see which airlines are faster than others on average. That's our task. We can start with a representative flight. So for this example, I'm going to use JFK to LAX, and we can compute the mean airtime for each. So here I'm going to filter using string detect. We will cover strings in depth next video, so don't worry. But we're going to filter flights based on JFK in the origin and LAX in the destination. So I use string detect. It's going to return all the rows or only the rows that contain JFK in the origin and LAX in the destination. So here, great. In origin, we see just JFK, and in destination, we see just LAX. And I could also click on view for that. Now let's create a summary. So we're going to group by carrier, because again, we want to see what airlines are fastest. We're going to summarize, taking the mean of the airtime column, and then we can arrange. So here we go. Now we have carriers. We have 5 different carriers and some mean air times. But these values don't really mean anything to me. I don't know what AA is, I don't know what B6 is, and so on. So what we can do is we can pull in the airline name into our summary using a join. So we're going to match the carrier column in airlines to the rows of flight summary. And let's look at airlines. We see carrier and it gives us the full name. Here we're going to use a left join because we want to keep all of the observations in our primary data, which in this case is flight summary. We want to read in airlines, so we're designating, we're saying flight summary is our primary, airlines is our secondary or our foreign data, and we're specifying that we want to merge by the carrier column. So here we go. We've joined in. Now we have the full names. So I can see that AA has the highest, or excuse me, the lowest average, American Airlines. Right join is going to work the same as left join again, but it's going to keep every row in the second data rather than the first. So here I'm keeping everything about this line the same. I'm just making it a right join instead. And here we see that we've kept all of these airlines, even if they're not in that original summary data. So this one isn't super helpful because we have a lot of NAs. We can also expand our analysis to include more flights. So let's say we want to include LGA to Atlanta, for example. Here I'm creating a new summary, I'm opening flights, I'm going to filter again, so I'm adding in more filters, origin LDA, destination Atlanta, and what I'm going to do now is I'm going to mutate. So I'm going to create a trip column where I'm going to combine JFK and LAX and LG and Atlanta into one column. So string combine, again, we'll get to this in the next video. Then I'm going to group by the trip and the carrier, and again, summarize. So here we are. Now we can see JFK to LAX has a mean airtime of 327 minutes. LGA to Atlanta has 122 minutes, and so on. Moving back to our code. Now let's say again, I want to have the full airline names in this summary data. I'm going to do another left join, again specifying that we want to join by carrier. And now we have the same thing. Our carrier, American Airlines, Southwest, and so on. We could also do an inner join, which only keeps matching observations in our primary and foreign data. So let's try that. And you'll see here they look the exact same. The reason is that we only had those original matching data sets. So it's only going to keep what is in both. Here it's functionally the same as left join, but let's say we had some data that we did not have a match for in our secondary data here. So let's say in flight summary 2, we had some airline carrier names that was not in the airline's data, then those would not be included. Full join. Now full join is not appropriate, again, because it keeps all observations of X and Y. Not all the carriers in airlines are in our flight summary data, so it doesn't make sense to do this, but I want to give you the example. Here you can see, again, lots of NAs in both trip and mean air, and in general, we want to avoid those NA values when we can. So let's go back to our flight summary 2, and I'll go ahead and exit out of all of these intermediary data frames that I've created. We have flight summary 2. Great. So we have our trip, our carrier, and our mean air. And let's say we started with this, that we just had these columns that had JFK and LAX, LGA, and Atlanta. Let's say that I don't know what LAX is, and I want those full airline names, which is in the airport's data. So we're going to use a new data set here. We're going to use our airport's data. I want to see the airport names. Let's we're going to use pivoting and joining to get those answers. So I want to know what LAX is. I want to know what the airport data is. What we're going to do first is we're going to join flight summary 2 with airlines, just like what we did before. So here, great, we have this, we have our trip, we have our mean time, and we have the name again. My next step is I want to separate trip into origin and destination. So we're going to open flight example, we're going to use separate trip into these two columns. So we're going to call the columns origin and destination, and the separator that we're going to split on is that dash between them. So here, great. Now we have two different columns. Next, we're going to use pivot longer to spread these values across rows. So we're going to put these into a column called FAA, which is going to match the column in the airports that we're referencing. So going back up to airports, again, FAA is going to match this carrier code. So here, we're going to go ahead, we're going to pivot origin and destination, we're turning those names into temporary and the values to FAA. Now I'm going to rename name in my primary data, which is the summary data, because name means something different in airports. So again, name means the airport name. In my summary, it means the airline name. So here we go. We're going to go ahead and rename that just to make it a bit more clear. And in our example, great. Now we see airline has its own specific column, and it makes just a bit more sense. We're going to go ahead and use left join again to match airports to the flight example. So we're going to join by FAA because we've created that column here with the original summary, or the original origin destination column. And now we have lots and lots of data. So we have the airline, we have the name, which is the airport name based on this FAA data set, column. And then we have a lot of information here like latitude and longitude. So we can select only the columns we need. If we don't care about latitude and longitude, there's no need to keep it in this data set. Go ahead and do that. Looking back, now we're back to just the airline name, the mean temperature, this origin column, and the airport name. So we can go ahead and pivot wider again. So we see here, temporary has origin and destination. We can split those back up. So we'll pivot wider, names from temp, values from name, and we can arrange in order of origin and mean. Oops, I have the wrong name in here from when I was adjusting this earlier. There we go. Now we have this in order. We have our mean air time goes from American Airlines is American Airlines going from John F. Kennedy to Los Angeles is our greatest time. Our smallest time is Southwest going from LaGuardia to Hartsfield. So, I mean, that's not the most interesting question, but you can see a few different examples of pivoting and how we can join data to go from initials to full names. And here is all of those steps just in one pipe or one group of pipes. Here we go, we've produced the same thing. So we went from this all the way to this, turning these initials, so JFK, LAX, and AA, into full names that make a bit more sense to the reader. Let's go ahead and practice filtering joins. And again, like I said, these aren't as common, but I do want you to know that they exist. Semi-join is essentially an alternative to filter. So let's say in this example, we want to analyze in more detail the flights that make up flight example. We're really interested in those routes. We want to return only the original flights data and just do analysis with those. So what I'm going to do is take flight summary. I'm going to separate this column, this trip column, into two separate ones, just to make it easier. Great, we're back to having two different columns. We could use filter. So we could say filter origin in, and then specify flight summary 3, the origin, destination in, flight summary 3, destination. Great, and so we're going to get an origin and destination. Over here, origin only the origin airports that we specified, or we could make this a little bit easier using semi-join. So we're going to create a new data frame, open up flights, and then we're going to semi-join flight summary 3 to flights by origin and destination. And here we go. Great. So now everything in flights is reduced to just what is in, what airlines in origin and destination are in flight summary 3. And we can double check. Distinct. Great. So in flights, we only have LGA and JFK in our origin and Atlanta and LAX in our destination. And we could also filter out flights to include everything but these 4 flights, so LGA to Atlanta, JFK to LAX. Let's say for some reason we are sick of them, we don't want to think about those ones anymore. We can use an anti-join to exclude those. So anti-join, flight summary 3, we're specifying what columns, and we see here, great, in origin, we no longer have LGA. Oh, if we open up the whole thing, sorry, flights anti-join, we still have the LGA, but it's not going to be to Atlanta. So if we look at origin, LGA is now to IAH, JFK, MIA, and so on. So that's a bit on joins. In our next video, we will cover